paper was majority is from like Rus paper, and some from, I don't have your schools because they don't release the paper, but Sydney boys, yeah, they have a very similar type of questions too. So I think the mix up North Sydney and Sydney boys, North Sydney and Rus for this paper too, which means you can have a very similar type of questions in your exam coming. So if you felt difficult for these type of questions, then make sure you practice, especially those who have exams in 3 weeks. Okay, these are the type of questions you will face in the exam. And the thing is, I don't think your exam will be 1.5 for this term too. That's the maximum. So most likely from 55 minutes to around 70 or 80 minutes. So you need to prepare how to manage your time during the exams when you're doing this. All right, let's see from the question 1. A spherical asteroid has a mass of 3.1 times 10 to the power 22 kilo and the radius of the 5.3 times 10 to the power 5 meter. What is the gravitational field strength at the surface of the asteroid? So just simply you need to use that to find the F or the G is equals to gm over r squared. Yeah. Substituting the value is in, you will get the answer. That is C for question 1. So easy question, don't lose any mark for these type of questions again. 2, Galileo's analysis of the projectile motion differed from that of the previous idea in that, okay, always think about in the projectile motions, the key point of the projectile is there are 2 components and happening simultaneously. So only that answer that I'm describing Galileo's analysis is D. So realize that the vertical and horizontal motions of projectiles could be analyzed separately. Okay. 3, why are rockets launched from the site near the equator? So thinking about we actually didn't think about why we do that. In the equator site, this is actually related to some of the questions we had. When the Earth is rotating, self-rotating in this way, okay, this is the point. Above that point is actually the point we can get the force from the Earth's maximum. You can think of if something ball is spinning, when the ball is spinning, okay, the maximum centripetal force we can receive, that is the boundary, not on the top or the bottom of the balls. It'll be somewhere here. So when we launch a rocket from here, going over there, what they do is it receives the gravitational field strength of the Earth. It will gain something called like this. This is called a slingshot. Slingshot effect. So due to that, the answer is C. The Earth's rotational velocity is greater at the equator, hence helps reduce the fuels required during the launch. Okay. Question 4. A projectile fired at the speed of the U at the angle theta to the horizontal reaches the maximum height of h. When the sample projectile is fired again, the same angle with the new higher initial speed, it reaches the new maximum height of the 2h. What is a new initial speed? So what you have to think from here is the u. Okay, so the angle is a constant value to reach the maximum height of the h, and then 2h of that too. The answer for that is actually the C, that root 2u, that it has to be increased by the root 2 for the relationship. Okay, question 5. A marble rolls off the 1 meter high horizontal table with an initial velocity of 4 meters per second. How long will it take the marble to hit the floor? So you can imagine that marble was rolling down the floor like this too. You don't need to worry about the initial velocity. All we have to concern is 1.0 meter, which is the maximum height in here. So you can think of like the u, y was 0, but sy would be minus 1.0 meter. AY would have been minus 9.8 meter per second squared. Using that with the SY equals to UYT plus half AYT squared, you simply get the answer, that is C, the 0.45 seconds. 6. A 200 gram mass is swung in a horizontal circle. Horizontal circle, as is shown It completes the 5 revolutions in 3 seconds. The circle has 2-meter diameter. Alright, then which was the following forces is closest to that required to keep the mass moving in a circle? So thinking about this, we have the complete 5 revolutions in 3 seconds, given the 200-gram mass in here. So I think what we have to find here is we need to find the force, the centripetal force, which is mv squared over r for that. Yep, so the radius is given, is 2 meter. As a diameter for 2, so radius 1.0 meter. Mass is given as 200 grams, which is equivalent to 0.2 kg in physics. What else? We need to think about how to find the velocity. Then velocity, as we're given the 5 revolutions, or 5 reps per 3 seconds. Okay, so how long would it take for 1 revolution then? Or how do you find the v? If you know the v is equals to 2 pi r over t, then we can just find the t, which is time taken for the 1 period. So if you take 5 revolutions for 3 seconds, means that for 1 revolution, it'll be 3 on 5 seconds. So that is your t value. Substituting that over here and the pi, you can get the v value simply over here. Okay, now we got the m and r, and substituting every value in here, Fc, you get the value of the d, 20 newtons, closest to. Edward, do you get it? All right then, 7. A satellite is in a high orbit around the Earth. A particle of the dust in the same orbit. Which row of the table correctly compares the potential energy and orbital speed? Okay. What is the main difference between, okay, think about the high satellite is in the high orbit around the Earth, a particle of the dust in the same orbit. So when the satellite and the dust in the same orbit, first of all, they would have a different potential energy. It's pretty simple as great that different mass would carry a different potential energy too. You think about how I'm lifting my cup up, lifting this pen, these two, even though they're in the same height, they will have a different potential energy. Or you can think about the gravitational potential energy is U is equals to minus G m over r. You can use that as well here, where m is the mass of the object. So due to that, they will have a different potential energy, so either A or B. The problem is, will they have the same speed? Yes. Mass is not the factor that determines the speed when there's orbiting motions, so it'll be the A. That's very interesting, which means that dust and the satellite will move in the same speed around the Earth. Good. 8. A satellite is moved from the geostationary orbit to the higher orbit. Which statement about the orbit change is correct? So the answer for the question 8 is simply the C. That the work done is difference. The work done is the difference between the gravitational potential energy of the higher orbit and that of the geostationary orbit. I'm expecting that you will get very similar questions in your school exam too. So examiners love to play with the, hey, what happened to their energy when we just moved the satellite from the low orbit to the higher orbit? Okay, so think about that kind of questions of concern. Prepare them. 9. A satellite is moving in a circular orbit of the radius 7 times 10 to the power 6 meter around the Earth. If the speed of the satellite is 8.1 times 10 to the power 3 meters per second, what is a centripetal acceleration? So simply AC is equals to V squared over R. Substituting the values, you get the answer that is A, 9.4 meter per second square. 10. The International Space Station's orbit Earth at the altitude of approximately 330 kilometers. Another satellite, Meteosat, is a geostationary orbit at the altitude of 36,000 kilometers. Which of the following correctly compares the orbital velocity or orbital period? So, Minchan, what happens when we increase the the radius, in terms of the velocity? When the r is increased, what happens to v? Does it? Does it? Thinking of R means that it's near at the Earth. So that's a short of R1, Earth, and that's R2. When the satellite's orbiting near at the Earth, think about the simulation. Think about the simulation I showed. This is why I gave you the visual cue. Just need to remember that. When the satellites are near at the Earth, they're orbiting faster. They're orbiting faster. Why? Why? Yeah, greater centripetal force, more velocity. Due to greater centripetal force means that do they experience a greater acceleration? Greater acceleration means that do they experience a greater change in velocity in every second? That means that the greater velocity too. This is how we need to interpret. So from here, International Space Station ISS would have the greater, so either A or C. Now, what about the period? So it means if these R2, the meteor set, is orbiting slower. It's kind of common sense. If something moving slower means that it takes a longer period of time to complete the one revolution. So that answer for that 10 is C. Guys, be prepared for these type of questions. This is some questions we love by the examiners and school teachers. 11. A 60-kilo object has a weight of the 240 newtons on the surface of the planet X. What is the acceleration due to gravity of the surface planet X? Very easy question. You just need to think about weight is equals to mass times the acceleration, or the g. So that we got the given 240 and 60. So 240 divided by 60, you would get 4. Answer is B. Next one, 12. The graph shows how the gravitational potential energy EP of the satellite changes with its altitude. So we see that, you see like when the altitude is at 0, the gravity potential is almost like a minus 10. So that it increases as we increase the altitude. Now, what is the change in the gravitational potential energy of the satellite when its altitude is reduced from 1400 to 4,000. So let's think about 1400. So it's here, there's a 1400. Use a ruler, pick up the point. That's showing you that gravitational potential minus 3. So initially, EP initial was given as minus 4 times 10 to the minus 3. I'm sorry, minus 3 times 10 to the power of 9 joules. Now EP and the final stage, okay, we have a 4,000 over here, so that's 4,000. Use your ruler, determine that, that's about 5.5. So it's around the minus 5 point, roughly about 5.6 times 10 to the power minus 9 joules too. Changing point energy means that EP would be final minus the initial. So minus these two values for question 12, you'd get the answer B, which is approximately 2.8 or 2.6 closest to. Got it? Okay, simply use the graph given. Let's do it for question 12. So we have given some data for the orbital periods of Moon, the Earth, mean orbital radius of Moon, the mass of the Earth. Now, what is the centripetal force experienced by the Moon due to the Earth's influence? All right, how do we calculate that, Jeremy? For question 13. So FC is mv square over r, as we need to find the centripetal force experienced. But how do you find the m? We know the m, what the m is. Okay, the problem is how are we going to find the v? Very good, using the 2 pi r over t. You're given that the radius is given, mean orbital radius of the Moon. Okay, the period, the mass orbital period is also given in here too. So period means that the time taken for the one revolution. So using that two information, you can find the v, hence you can find the FC value. Pretty easy. So the answer is A for this case. 14. What is the orbital period of the Earth? And of an Earth satellite having an orbital radius half that of the Moon. So the r is now decreased by half. That's the orbital radius. Okay, how do we do this? 동일. If the orbital radius decreased by half, divided by 2, yeah? Very good. We can use a t squared over r cubed is the same as a constant value. It's a satellite. So if that's a moon stat, then satellites t squared over r satellite cube is also be the same, using the Kepler's second law in that, third law in that case. So substituting the rest of the values too, you can determine the value, then you get the t, which is equivalent to 8.34. So answer is a V for this case. All right, last multiple choice question 15. A car can safely negotiate a corner when it's traveling at the speed v. What changes would ensure that the car could safely negotiate the corner if it was traveling at 2v? Edward, what is this question about? Circular motion. And? I mean, there are many types of circular motions, you know. So from that many types, what is specifically what type of the circular motion that the question is asking in here? Yeah. When the car is turning a corner, okay, I've been emphasizing that that's a circular motion, so the net force would be just simply the centripetal force. Yes, but what makes the centripetal force when the car is turning a corner? Friction. That's the point of this question in here. So when the V is increased, basically you increase the centripetal force as F equals to mv squared by r. So the answer that matches that explanation is actually D. Increase in coefficient of friction between the car and the road by the factor of the 4. Why 4? Why can't it be 2? Yes, it would be mv squared over r. You increase the v to the 2v means you increase the v square, would it be 2v of the square value. So that the coefficient value must be increased by the 4, not the 2. Yep. Easy. All right, 16. Let's move on to the long responses then. Any questions in the multiple choice? Did everyone get 15 out of 15? Don't use not. Okay. Vincent? Okay. Edward? Okay. 13 out of 15? Jeremy? You think?
No, fine.
Did you get like 13 out of 15?
Yeah.
Okay. 13 is roughly about 80%, so told you it's pretty hard to get 80% in the exam sometimes. All right. Question 16. An experiment was conducted to measure the value of the gravitational acceleration g at the two different locations, x, which is like a north pole here, or different point in the south pole here, y on equator. Outline the possible reasons for the difference in the value of the g found at x. Okay. First of all, you need to think about how to measure the g. The g is measured by g m over r squared. This is how we measure the g. As fg was known as g m m over r squared. So we can kind of ignore the m value, the mass of the object. Okay. So using that, I mean, if you know that, like, Earth is not a perfect, like, in a spherical shape. It's basically a bit of like an elliptical shape too. So it means that from the center over here, the distance from the center to the x and distance to the y, as you can see from that, they're not the same. It's actually the longer from the center of the Earth to the equator. So we can think about the greater the r. How does that affect the g value then? If r is increased, greater r means that g value would be decrease that too. So which means that we, as at the equator, it's a slightly longer the radius than the what we measure for the south pole. The gravitational force or gravitational acceleration experienced at y would be greater. G at y would be greater than G and x. This is 1 mark. Okay, anything else? Any other suggestions about like difference of the G, possible differences between G? Thinking about this, X is like, when we're thinking about the self-rotation of the Earth, assuming that it's rotating like this direction here. Okay, so Y is the point where they get the maximum rotational velocity. So you can assume that if a person is standing on the Y over here like this, compared to a person standing on the South Pole, like that over there too. As Y is the point where we get the maximum rotational velocity, rotation speed of the Earth. Okay, means that it will generate some sort of the centripetal force towards the center, making the maximum value. Compared to the Y over here, the X here, this is a pivotal point. So there is not the central point. There will be not much of the centripetal force experienced by the person. Then how does that affect? That makes what? As at, is that Y? Point Y, as at Y experiences the maximum rotational, which is a centripetal force, that reduces it reduces the amount of the magnitude of gravitational acceleration to that too. That'll be the other one here too. So as pointed on the Y, they experience a centripetal force as well as gravitational force. It will actually reduce the magnitude too, compared to the Y. Means that purely the G value on the X would be greater than G value at the equator. The last thing is probably the density, but don't worry about the density of that, the crust. Okay, we don't study geology here. Okay, this is how you get the 3 out of 3. So 2 points, at least 2 points. And then thinking about Y, the point at Y would be greater than, X would be greater than Y.
Isn't Y greater than
GY. Oh, sorry, for the first one, yes, it's a greater, the length. So it's from the diagram here. So that means in that case, G, X will be greater than GY. So they'll be different. Okay. Now, question 17. Define the term escape velocity. Edward, how do you define the escape velocity? Is that how you define it? Oh, I hope you didn't write that in your answer. Ooh, that's not how you define it. No, the questions are clearly saying define the escape velocity. Okay, so it is what? The minimum velocity required to escape. Now, escape from what? Escape from what? From Earth. What do you mean by the Earth? Escaping from something. Gravitational field. There is a difference between force and field and the gravity. Earth is not acceptable though. Okay, that's like, come on, year 10 answer. Let's use year 12 content. See, gravity. That's the minimum velocity required to escape from the escape from the gravitational field. Okay, that's gonna be one. Okay, then how do we measure how do we calculate the the escape velocity, Jeremy? Pardon? How do we get that? How do we, no, it's not there. It's not there. Oh, do we have that? Okay, maybe. How do we get that formula? See, I'm not giving the questions that you can just simply memorize and write the answers. And that's same for the school teachers too. They were not going to give you define it. So you got to tell me how to find the escape velocity, how to express the escape velocity. Minchan, any ideas?
Potential gravitational acceleration plus kinetic energy
Yeah, plus is?
is
I'll make it really simple here. It is the velocity when the total mechanical energy is 0. In other words, the sum of the U and K is 0 too. Okay, I show you this because we had the questions like this before. How do we find the this? We know the U plus K equals the total mechanical energy. When this is 0, okay, we're going to simply use Gm m over r squared minus plus half mv squared equals to 0. Move that, then you get the half mv squared. That is equals to Gmm, oh sorry, it should be r, not the r squared. R squared is for the force. Gmm over r. Cancel out the m. Then what do you get? V is equals to 2 Gm over r and square root of that. Is that something you memorized? This is how you get this formula. Okay? You don't need to show that expression here because it's not a definition, but I'm just showing you how to get that. So be careful. I don't like to see like just simple formula in your answer, define questions, because I'm not going to give you any mark for that, nor for your school teachers, so be careful. Okay, that is a definition of the escape velocity. Guys, make sure you play with the simulations I shared. Make sure you do that, because it will give you a perfect visualization of the formulas, why we're working that too, in terms of the energy. Very important. All right, 18. Calculate the work done when the 150 kilo satellite is raised from the altitude of the 1,000 kilometers to an altitude of the 5,000 kilometers above the Earth's surface. If the radius of the Earth is given at 6,380 kilometers given. Okay, Jeremy, how do you find the work done? Oh, change in potential energy, because we did that yesterday. I'm asking, this will be combined, the module 6 too. Work done is found by a change in K or something change in U. Okay, this is something we learned in module year 11, module 2, that about the work done. Then how to find the work done? So means that as we are only given that different altitude, 1,000 and 5,000 here, you gotta find that change in U would be what? The final potential energy minus the initial potential energy. So you gotta determine which is a final, which is initial. Final here, it was raised altitude to the 1,000 to 5,000. So 5,000 is your final value. So all you need to do, I gotta show this, Gmm over r final square minus, oh I keep saying minus final square there, ignore that, sorry, G minus Gmm over r initial like this. Then what you get is, this comes out, it comes like this, Gmm comes out the front, and you only simply get r initial minus R final beautifully. See that? Okay, time to substitute the relevant value. G 6.67 times 10 to the power minus 11 times mass of the Earth, 6 times 10 to the power 24 times the mass of the satellite, 150. That times the R, we have 1 over R initial was given as 1,000, but you need to include the radius of the Earth, which is 6,380. And we need to change that unit from kilometers to meter. So just simply saying 7,380 times 10 to the power 3. Show that conversion of the kilometers to the meter. On final, we have the 6. So 5,380 times 10 to the power 3, like this. Then time to play with your calculator, substitute the values. You should get the value of 2.9 times 10 to the power of 9 joules. 3 marks. 3 marks. Jeremy, why do you think it's 3 marks? Oh yeah, that's not include the marks, but if you don't do that, you lose mark. You just simply lose mark. It's not included. Yeah, so you're gonna get a mark. This is how we mark it. I will see whether you use the perfect work done equals that. This is 1 mark. Yeah, that's 1 mark. If you didn't write that, you lose 1 mark. And then show that too. Guess what? Substitution and everything. You think this is complicated? That's only 1 mark. This is how we mark for 3 marker questions. So, even though you had some mistake in here, maybe like some wrong substitution, that's okay. You only lose 1 mark. Okay, maybe the substitution in there is a 1 and 1, 2, depends how you substituted the values. That's important. Okay, so think about why the questions are 3 or 4, 5 and 6, sometimes 9. Yes, you will go up to the 9 markers in the HSCs. You need to get prepared them. All right, B. Explain whether the satellite's gravitational potential energy has increased or decreased as the result of this change in the altitude. Dongyu, is the gravitational potential energy has been increased or decreased? It's increased. Think about the U is minus G M over R. Increase the R. Increase the R means that we are getting more. The value is getting reached to 0, which is bigger, the value of the U. Yes, this is why purposely they give you the questions like this. Okay, but work done. When you increase the, so this is how we prove it. When we deduct the value from 1,000 to 5,000, you see like work done is required here. You need to push it. You need to push it so that potential energy is being increased too. One of the favorite questions in Module 5. All right. Can I move to 19 then? An enemy ship was anchored 2 kilometers from the coast. A cannon on a 100-meter high cliff fired a cannonball with an angle of 20 degrees to the horizontal at a speed of 150 meters per second. Okay, a horizontal component and that too. So basically you can use the vector diagram here, 150 for the initial velocity. Make your habit to draw the vector diagram, the 150 for U meters per second. That's a 20 degrees there. So that's Ux and Uy. The question is asking you how to find Ux and Uy. Uy is found by U sine 20. That's a U cos 20 there. Substituting the value, I tell you one thing. Horizontal component, therefore, it should be the 141 meters per second and the direction. And the direction to the right. Direction. So it's a 51 meters per second. Up. Direction. Didn't write the direction for 2, you get 0. Yeah. Up. And to the right or forward. Did the question say the magnitude? No. Read the question very carefully. This is actually the huge mark deducted by the students. Probably the stupidest mistake. It's not a mistake, they didn't know. They didn't know, they didn't write the direction. But I'm telling you, you need to write the direction. Unless the question is not mentioning the magnitude. Okay? B, then calculate the time taken by the cannonballs to reach the maximum height. So simply use max height and max height. That's an easy question, and Vy is a 0. Using that, you to get the time taken, Vy is equals to Uy plus Ayt, where the Ay is minus 9.8. So that the time taken for that is 5.2 seconds. Too easy. It's only 1 mark a question. C, calculate the maximum height above the cliff the cannonball reaches. So you have the time given here, 5.2. You can use the Sy. So Sy is equals to Uyt plus half Ayt squared. Substituting the values, you get the Sy value above. So that Sy is displacement from here. So at the end, you need to add up the value of the 100 as well too. As a result of that, the height of the total height would be 134.3 meter. Yes. Oh, sorry, above the cliff. So that means the Sy simply be the 134.3. So ignore the 100. My bad. That will be related to question D. D. Does the cannonball strike the enemy's ship? Show your reasoning. Will it strike the ship or not? So the enemy ship is about like 2 kilometers away. 2 kilometers. So the range, they need to cover 2 kilometers. So let's say whether the range of the cannonball to find the total time taken. How to find total time taken? So Sy, when the cannonball goes up and down, means what would be the Sy's vertical displacement? There we go. This is something that you need to use. Okay, minus 100 is equals to Uyt plus half Ayt squared. So use that. Got the Uy value 151 and 51t minus 4.9t squared. Move that 4.9t squared minus 51t minus 100 equals to 0. T would be simply quadratic. 51 plus root 51 squared, 4 times minus 100 times 4.9 divided by 9.8. So for the time taken, 51 squared, 4 times minus 100 times 4.9, square root of that, plus 51 divided by 9.8. You should get 12.09 or 9 seconds for the total time taken to. Then Sx, which is range, is Uxt. Showing you that as you have given that 141 times that 12.09, you get 1,705 meter, which is what? Less than 2 kilometers. So that it will not hit, it will not strike the enemy ship. Okay, or you can use the time taken value from the C over here if you like to. I don't mind to see that too, but I've been emphasizing this. Easier to use the quadratic sometimes. 20. The Jason-2 satellite reached its operational circular orbit of the radius 1.35 times 10 to the power 7 meters in 2008, and they began mapping the Earth's oceans. The mass of satellite is given as 525 kilograms. On the figure, draw the one or more label arrows. Label arrows to show the direction any forces acting on the Jason-2 satellite as it orbits the Earth. Did anyone use a ruler? Did you use a ruler? Yes, you use a ruler. Any situations you have the circular motion, the centripetal force with the net force. So say that, okay, label that as this. Don't show FC. I don't know what the FC stands for unless you mentioned it. So unless you labeled it. So you can just say centripetal force, which is FC. Now you can set it FC. That's equivalent to gravitational force. That's Fg. That's what you need to do to the perfect labeling. B. Calculate the orbital periods of this JSON-2 satellite. Let's calculate the orbital period then. We're going to use the Kepler's law, T squared over R cubed is equals to 4 pi square on GM. This is something that we're going to use for question B. Okay, you may be questioning, hey, so when do we use that? When do we use this formula, and when do we use that Kepler's second law too? So, in the case you have a two or more orbits, you're recommended to use the Kepler's second law, which is the T1 square over R1 cube equals to T2 square over R2 cube. In a case you just simply need to find the one's orbital speed, this is recommended. In that case, make sure you put it into the standard unit. T for the seconds, R for the meters. So that the T here would be equals to 4 pi square times R cubed on GM. And just simply substitute the values we have. We're given, beautifully given in the meters there. The T you should get is 15579 seconds if you substitute it correctly. Do not need to convert that into the hours. Just put it, just leave that in your the sig fig. Okay, and the sig figs for that is, as we're given 3 sig figs, that's approximately 1.56 times 10 to the power 1, 1, 2, 3, 4. 4 seconds. This is what you need to do in the 3 sig figs. As I said, if you didn't do it, you'll lose 1 mark. C. Calculate the speed of the JSON-2 satellite. How to calculate the speed? That V is equals to 2 pi R over T. As we give it the T, substitute the R and T values, then you'll get approximately R value and T value in the kilometers. You'll get 5.4 times 10 to the power 3 meter per second for the question C. Okay, we don't have 21. I just delete that question, so 22. This set of data was obtained from the motion investigation to determine the acceleration due to gravity on the planet other than Earth. So we have a time and V and plot the data gives. So you actually get the data like this. So started from the 0.4 and down here. Okay, you get the data up to on the top 0.3 over here. And you get the line of this. If you have to plot the data correctly. Okay, and then calculate the acceleration. Now, how do we calculate the acceleration, Dongyu, for this graph? Yes, as we have a velocity versus time graph, find the gradient of that too. Okay, in your answer, I would like to see the right angle, whether you chose the point over here, so I take the point over here and there. I want to see that. I actually want to see that, and then show the gradient of the velocity versus time graph is equivalent to the acceleration. That is y2 minus y1 or x2 minus x1. Make sure you show all the relevant working out. So if I plot the point, 0.25 minus 1.86 minus 0.44, that's one example you can have. That's 0.176. Now, given sig fig is 2. So fix that into 2 sig fig, 0.18 meter per second squared into sig fig. Final answer. The range could be around to 0.17 to 0.19, but that's it. If you didn't get the value near at 0.18, check your calculation, check your skill. Everyone good? 22 easy. 23. All right. This is the questions probably I need to spend a lot of time. Consider the following thought experiment we have. Okay, two towers are built on the Earth's surface. The height of each of the towers is equal to the altitude of the satellite in the geostationary orbit around or about Earth. Tower A is built at the Earth's north pole, and the Tower B is built at the equator. Identical masses are simultaneously released from the top of each tower. Explain the motion of each of the masses after their release. This is actually one of the past HSC questions many years ago. And yes, they are actually following the trends of these type of questions too. Jeremy, what's the main difference between Tower A and Tower B when we release the ball from Tower A and B? Even though the tower has the height of the geostationary orbit, when you release the mass from there, what would be the motion of the ball? For Tower A, yeah, down. So, how would you describe the motion of the ball?
Figure
8. 8. 8.
Yeah. Not an 8, correct.
What do you mean by that? Like, no. When you just kind of drop the ball from Tower A, which is right at the North Pole. First of all, will it get, okay, what is the property of the geostationary orbit? Edward, what was the property of the geostationary orbit? Yeah. So the period T is 24 hours. Okay. Anything else? Any condition for the geostationary orbit? So the satellite must be at the equator. Why is that? Why do you think we need to replace a satellite at the equator? Not above, below, but right at the equator. We had that in the multiple choice, by the way. What is the benefit of putting something at the equator? Thinking about rotating a ball, yeah, rotation of the ball. I mean, I'm not talking about ball, it's actually the Earth too. When you place something at the equator, this is the point where they receive the centripetal force in the max. But when you place something on the pivotal point here, like this, can you see that? This is the equator. So when I place something over here, it receives the centripetal force in the maximum value. But when I place something over here, basically there's no effect of the centripetal force. Does it make sense to you? So the point is, they get the maximum rotational velocity at the equator. This is why at the geostationary orbit we intend to place that satellite at the equator so that they can gain the maximum rotational velocity of the Earth. Okay, so Tower A is at the North Pole, as you can see. When you're dropping a mass from there, it will be a simple projectile motion. As the Tower A, the ball will go down like this. Okay, the only force acting on that would be the only force acting on the mass A will be the gravitational force, which is downwards. What about the Tower B? Tower B is the one that's at the equator. So when you're dropping a ball, you can imagine that as soon as you're dropping a ball at the equator, it will start gaining the rotational velocity, same rotational velocity as that too. So we can use this property of the geostationary orbit here. The mass will be rotating around the Earth in the same period as the Earth too. Why is that? Because it's not gaining, the gravitational force is now converted into the centripetal force. So that they were making what? Something called the circular motion, or the orbital motion around the Earth. Does it make sense to all here? Okay, this is my one pick. Thinking about when you're rotating something, the side that get the maximum velocity, maximum radius, would have the maximum centripetal force, which is equivalent to whatever you're putting that exerting that centripetal force there. Pivotal point, if you think about the rotation, doing your experiment here, it is the rotating ball that gains the maximum velocity, maximum centripetal force, not your hand. Your hand is a pivotal point. So you feel actually tired. You actually feel the gravity is pulling down. It's a good example of that as well too. Everyone good? About 23? Minchen, you good? 24. Okay. A rocket launches a satellite into an orbit 350 kilometers above the Earth's surface. The weight of the satellite is 14 kilonewton at launch and is 12.6 kilonewton when in orbit. Why does the weight of the satellite changes? Okay. I mean, if you say like, oh, because they're consuming the fuels, yeah, maybe. It's reducing the mass. I take the one factor too, but it's mainly about when you're going up, 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 up. The weight. It's about the weight, not the mass. Weight is what? mg. Increasing the r means what? G will be decreased. Therefore, weight will be decreased too. This is what we wanted in your answer. Not because of like they're consuming the fuels, though. I mean, yes, could be one factor. Its mass m also increased too. The weight will be significantly decreased in that case. B, calculate the orbital velocity of the satellites. So how to calculate that? To calculate that, orbital velocity, Fc, equals to Fg. This is something that you need to use. So what we know is mv square over r is equals to g m over r squared. Cancel out the m, cancel out the m, r and m too. So v will be simply equals to square root of g m over r. I would like to see that in your answer, the working out. Not just simply v equals to, I mean, because in trials sometimes like they just put the v equals to root gm over r, but this is the for working out. Show the all the substitution for the r, okay, it's at 350 kilometers above the Earth. So r is the altitude, which is 350 kilometers plus radius of the Earth. You need to include that in your answer, which is 6.030 times 10 to the power of 6. So the final answer for that is V. You should get 7,692 meters per second. Convert that into given sig fig, 3 sig figs. That's approximately 7690 meter per second. This is the final answer in 3 sig figs. C. Explain two effects that reduction in the altitude would have on the motion to the satellite. So, construct your answer. There's a 4 marker. Each of the factors will be contribute like 2 and 2, and you need to explain them. So let's go for the 1. What would be the one factor, one effect by decreasing the altitude mentioned?
Gravitational acceleration will be laid on.
Yeah, but in terms of motion, how does that affect the motion?
So it will be orbiting quicker velocity.
Decreasing the altitude means that increasing the velocity. Is that what you mean? Okay, why?
Because
I mean, there are many ways, there are 2, but you need to explain why. There's only 1 mark.
because the wave force equals centrifugal force.
Yeah? First of all, we can use this formula here as V equals to root gm over r. This is 1. Or, and I'd like to see that actually, what happens to the gravitational potential energy of the satellite when we decrease the altitude? The u, in other words.
It also decreases.
This it decreases, yeah. And as we decrease the u value, what happens to k?
It increases.
K increases as using the gravity conservation of the energy to here. So there could be two explanations for the increase in the v. One is as v is defined by root gm over r, yes, simple as that too. Or when the u is as we decrease the altitude, u value, the gravitational potential energy will be decreased. On the other hand, as it decreased, the k potential kinetic energy will be increased. At k is equals to half mv squared, it will eventually increase the velocity too. Okay, that's one. Two, Jeremy. Other effect, that's one. That's only 2 marks out of 4. Identification, explanation.
I think I said
When r is decreased, then
period has nothing to do with motion.
hmm?
Period has nothing to do with motion.
It does.
Why?
How do we know something's moving? We need to think about the time taken for that motion too.
Lower means spread out period. Like faster period. Shorter period.
Shorter period, even
Yeah.
shorter the period. How are you going to explain that? How are you going to back up your explanation?
Because like once you increase the velocity,
Mm-hmm.
then intensity increases too. Because like you need to follow.
Yeah, well,
Then
no, you got to use, yeah. As this is the constant value,
Yep.
as we decrease the r, t must be decreased as too. Okay? You can either use that or that. Well, like for me, like I would like to see some good explanation in here too, because this is why I give you so much space to write your answer. Okay? But you can split. Think about if you ever have a question like, hey, what's the 2 reasons? What are the 2 effects? Split your question into 1 and 2. Okay? Make that as your habit in your structure. Structuring your answer. All right, that was 24. 25. I'm wondering how everyone go with this. In 2014, the James Webb Space Telescope JWST was placed in orbit around the Sun. Earth and the JWST will follow the orbit as shown with the identical orbital period, which is 365 days. This appears to contradict the Kepler's law of the period. Okay? Why is it possible for JWST to orbit the Sun with the same orbital period as Earth? In your answer, refer to Kepler's law of the periods. 3 mark questions. Why are we saying that JWSTs are violating, contradicting the Kepler's law of 동률? Comparing, thinking about the radius, like the orbital radius of JWST to the Earth. 동률, which is longer, the orbital radius of the Earth or the orbital radius of the JWST? Is it bigger? Didn't we just discuss that? When the r is decreased, the t will be decreased too. So, thinking about the t of the Earth or the t of the JWST, according to Kepler's law, that means that t must be less than, though it will be shorter. It will be like shorter than the JWST. Sorry, but it is not true. I mean, it's given the orbital period for the JWST and they are the same. So you need, first of all, in 1 mark question, 1 mark is you need to explain why this is contradicting the Kepler's law. And second is you need to explain why, how did they overcome. Any idea, Edward? Mention? Oh, sorry. Mention. Any ideas? Why do you think the JWST has the same orbital period as the Earth, which is 365 days approximately?
Maybe it has a rate of velocity.
Yeah. Okay, I take that. the velocity of the JWST is surely greater than velocity of the Earth. If thinking about it, greater the orbit, greater the circular track means you need to run faster, to run as like someone inside in a track. Okay, but why? I mean, cause that's actually contradicting the Kepler's law too. Because we just discussed that when something's close to the track, they're running faster. But somehow JWSTs are running faster than the Earth, orbiting faster than the Earth. These phenomena, this observation cannot be explained when we're just thinking about the G from the Sun. This is not explained by, cannot be explained by the G from the Sun. But JWST, which is the telescope, compared to the mass of the Earth, so relatively, significantly, they are small. So that when JWST is near at the Earth here, it will be affected by the gravitational field of the Earth as well. Does it make sense? So for JWST, its affection, it will get affected by G from the Sun, as well as G from the Earth. Now it gets a double of the acceleration, one from the Sun, one from the Earth. Then what happens? It has a greater acceleration before that than the Earth. Does it make sense? Greater acceleration means that every second it will experience the change in velocity significantly. Does it make sense? That means that as the JWST currently experiences a greater acceleration, it will gain the greater velocity. Therefore, it is possible for the JWST to have the same period as the Earth, like this, even though it has a greater orbital radius than the Earth. So it is not contradicting the Kepler's law. Okay, it is the application of the Newton's law, which is a gravitational field. When we had that in, I think that's 2012 or 13 HSC, when we had that, I remember my student, like our tutors, they couldn't answer that question because they didn't know how to do it. So, okay, but don't give up. Don't give up. Even if you don't know how to answer the questions like this, try to show some relevance. Each of the relevant things, okay? Try to think about how to get at least 1 mark. And 1 mark makes a difference. Come on, 89 and 90 is different. 79 and 80 is different too. And that makes a difference in band, that makes a difference in eta too. 26, easy question. Let's go quickly on that. An investigation was performed in which the motion of the projectile was analyzed. The apparatus was set up as shown. So as we did that last time too. Yeah, we did it many times. State the independent variable. Independent variable is the initial release of the height, the point where you release the ball. That's your independent variables. So H is the H, or the initial release, the height of the ball, is your independent variables. B, identify one way in which the validity of the investigation could be evaluated. So how do we ensure the validity? Make sure you have to think about all the variables, especially the control variables. Make sure you use the same ball all the time for the control issues. Make sure you use the same table. Make sure you use the same ramp. Okay, and try to use something that's frictionless. The frictionless ramp. That's also very important too. Okay, so you got to talk about any of those. One way means any of those control variables. Easy questions. 27. A student investigated the factors affecting the periods of the oscillation of the pendulum. The student set up the pendulum as shown below. So investigated how many complete oscillations the pendulum made for the different length of the pendulums. Okay, state the 2 conclusions that students should make from the results shown in the table here. So what we see is the length of pendulum is being increased, mass of the pendulum bob is actually being, okay, this is a little bit weird, but you gotta identify one. First of all is the mass of the bob. Mass of the mass doesn't really matter, it has no effect. That's the one conclusion you should make. As you can see, the mass, even though you change the mass, 100 here, 100 here, it just depends on the length of here. They have identical values. Second, as the length of pendulum being increased, the period of the pendulum as also increased too. That is the conclusion. So when the length is increased, the period is increased. All good? B, the student wants to be more certain about that her conclusions are correct. Suggested 2 ways in which the reliability of the investigation could be improved. Jeremy, how do we ensure that reliability? Yep, so repeating the experiment at least 2 or 3, yes. And?
I set the stopwatch.
That's not the reliability, that's for the accuracy. Guys, how do we ensure the reliability? I told you like there's a repetition and consistency, but if you think like they are so narrow of the data, the range is narrow. As we can see from the range of data here, the length, the student only used that 200, 400, 600, which is 3 data only. The range is too short. So to ensure the reliability, to make a stronger reliability, a reliable experiment, you got to increase the range of the data in that case. So you got to take a readings over the larger range and more readings in the same range. So repetition means that repeating the whole experiment set as well as repeating each of the trials too. So this is why the 2 mark. 28, it looks complicated, it's pretty easy questions actually. So you're given a golfer hits the ball from the point P and the ball leaves the club with a velocity V at the angle of theta. To the horizontal, the ball travels through the air and it lands the point R. At the T 2 seconds, the ball just passes over the tree. A, let's find the horizontal distance D. So we are given this one, Vx and Vy separately here. As we can see, the V has a constant velocity throughout the journey. It means that how to find the distance? You find the area under the curve. Then you'd get 60 meters for the area. Why? For the velocity versus time graph, the area under the curve is indicating the distance or displacement. Same for that. The height of the tree. When do we know the height? The maximum height. This is when the final velocity is 0. Final vertical velocity is 0, which is that point. That's the that is the point where we can determine this is the maximum height. So you just simply need to find the area for this triangle there, which will be 10 meters. Did you guys get the point of the questions? Easy, warming up questions actually. Yep. The height of the tree. Oh, height of the tree. Hang on, 2.2 second ball just passes 2.2 seconds over here. So you got to think about 2.2 second passes over the tree. So you got to find the whole area and that area and deduct the value. So that would be 10 meters. I misread the question. Okay, 29. A group of students used the conical pendulum to determine the acceleration due to gravity. Schematic arrangement of the experiment setup is shown below. We have given that so this is something that you need to think of here. This is the formula that you will never see again. I promise you will never see that again unless you're studying physics in the university. So you don't need to memorize, but you're given that. First up, filling up the values. Okay, you need to show in the 2 decimal point. That's also a very important part. So the correct answer for that is should be like this. You need to show your data value in the 2 decimal points, as you can see. Just matching up the 2 decimal or the 2 sig-figs points. Otherwise, you will lose. You won't get any marks for this question then. All right. And then question B was asking plot the data and use the gradient value, and D. This is the question that I will mark it through your papers too, and we'll probably see like how you're going with your skills and the gradient values too. Okay, so today we finish here. Okay, I'll leave some of the questions that you can try it too. So you can read my feedbacks about your skills about drawing the graph and find the gradient values, therefore finding the values too. But think about the gradient value is always be referring to that random formulas that we practice so many times too. Yes?
What would the units be
Unit 4.
for this the gradient?
Gradient has unit of the second square.
Second square.
And as the gradient has, you have a cos theta over here. You get the period square, t square, which is second square there. So it's a rise over run second square on the degree minus 2, or per degrees 2, like this. So that'll be the unit of the gradient. Okay? Any questions about the paper?